Hi students, and welcome to another lecture of our C# Fundamental course. This week we are going to discuss a very important and very interesting topic, and that is stack, heap and references. I have prepared something for you. On the left hand side you see an empty C# program. On the right hand side you see Excel. Well, it's not about Excel. This thing here, this dark rectangle here represents our memory. So let's say this is the memory of our computer. And you have to understand that the memory of your computer, at least conceptually, technically it's a little bit more complex, but conceptually your memory is split up into two logical areas. On the one hand side, let's maybe mark it like that. On the one hand side you have yellow, the stack. Let me write that down for you. This is the so-called stack. The stack is a very special memory. It's a memory where you keep small things, small areas of memory, things like basic data types like integers and double values and datetime values. They all live on the stack. Why this is important? You will see that later on. And conceptually, we have a second area which is way larger, and that is called the heap. So in blue, we see the heap memory. Heap, like a real heap, you can put things on it and it grows and grows and grows, and the heap can be very, very large. Essentially, the heap can grow nearly to the size of your computer's memory. That's technically not 100% correct, but yeah, let's assume that in the moment. Well, there is a remaining part here in memory. Of course it is. Let me mark that one in red, and this red memory is not available for your program. It might be the memory where your operating system lives, and so on and so on. We do not care about what's in this red part in details. It's just reserved memory that somebody else uses. Now let's think about what's going on when we allocate or use memory. And first, we will mainly focus on the stack. Let's create a very simple variable, int x, and assign it the value 1, for instance. In this case, this x has the data type int. If I click on int and press F12, you will see that int is conceptually in C# a struct int32. That makes sense, right? Because we know that integers have 32 bits. But the important thing that I want to note here is that this is a struct. We haven't created structs in our C# programming so far, and to be honest, in everyday C# programming, you do not create structs very often. Typically, you use classes or record classes, but structs, well, there are some cases where structs are really useful, but especially as a beginner, you typically focus on classes. However, we use structs a lot, and you have to understand that structs always live on the stack if they are not part of a class. There are exceptions to this rule, but let's keep it simple. If you just create an instance of a stack-based variable in your functions, they live on the stack. As I mentioned, there are exceptions to this rule, but for now, let's simply say structs live always on the stack, okay? You will learn more details about that later on. So what we can do is we can, for instance, say here in our stack memory, we have our variable x equals 1. That is the memory. It uses 32 bits, that is 4 bytes of our stack memory. When we create a second variable, for instance double y equals 2, something like this, then we can again click on the double, press F12, go to definition, and guess what? It is a struct again. So where does it live? It lives on the stack. So now we have a second variable here, y equals 2, that will also be memory on the stack. Now next, let's say a datetime, okay? Let's say datetime dt equals to datetime dot today. Let's say var, because now you're already an expert. I don't need to use the data types here on the left hand side. If we go to datetime, press F12, go to definition, then you will see that datetime is also a struct. So our datetime lives where? On the stack. Exactly, because the struct lives on the stack. Here This is now our DT, and that is 2023-11-09, because that is our today's date. Okay, that's fine so far. You might ask yourself, okay, so what? I mean, stack, okay. Wait for a second, we will see why this will become super important. Now let's create a function. Let's call this function, we don't need a function here, do something like this. And let's call this function, do something. I have a question to you. Can we access the variable x up here? Well, yes, we can, because x is a global variable here. Let's make this function static to make this example more useful for the discussion of stack and heap. So here, let's try that. Console log, I did too much JavaScript programming lately. Of course, right line, I'm sorry. Here it is. And you see that we cannot reference the variable x. This is because of the static nature of this function. We called about static classes, and we talked about static classes and static functions before. To make a long story short, static methods cannot access global variables. So therefore, this doesn't work. Why? That is the nature of the stack. You have to understand that each function gets its own stack. So we can say this part here, let's draw that a little bit differently. I will draw a thick bottom layer. So this above here, is the stack for our global area here. We can also, to make that more clear, we can make it like that, so that we have two different code blocks, as you can see. Now, this part here belongs to this code block here. And here we get a new stack. So when this function creates a variable int x equals y, guess what? This x is not this x here. It's a new x. It created here, this is the new part of the stack, and the function only sees its part of the stack. Okay? So if we create another variable y, we can even use a different data type. I can now, for instance, say this is a byte y, and let's say this is the value 3. So here we have y equals 3 because we are in our separate stack. This is a new stack. We also say stack frame to it because it's a kind of frame inside of this stack. Now, what if we create even another method? Static void do something else. Let's do it like that. And let's call this function in do something else. And when we now create again a variable x, int x equals 3, guess what's going to happen? This stack here is closed. So let's do it like that. And here we get a new variable, x equals 3. So now we have 3 different x variables. We have this x variable at the lowest stack frame. Then we have this x variable at the second stack frame here. And then we have this x variable at this stack frame up here. And it's important that this function here, do something else, cannot access the x variable of the caller, which is do something. So this is crucial in the way we write programs. Please remember, every method gets its own stack frame, and all structures live on this stack. Now, what happens if our do something else method is finished? So let's say here we reach the, I will write it down here for you, we reach the return statement and we return back to this do something else call. So here we are now, here we are. What happens then? The computer, to be more specific, .NET will, we say, clean up the stack. So it will remove this stack and we are now back at this stack frame here. This is now again our active stack frame. Okay? So what we can do is we can say, hey, remove the border here, sorry. Excel. I'm not an expert in Excel, so I have to say border. I want to remove that one. Let me get rid of that one. So now this is our active stack frame. And guess what? We are back to value x equals 2. Although there was an x down here, this x has disappeared. Why? Because we returned from the method and the stack was cleaned up. So what's essentially happening? The stack is building up or building down. Typically, you draw the stack in a computer program growing towards the bottom. Okay, so the stack is growing when we call methods, and it's shrinking when these methods are done. So we returned to one stack frame above, and now we have the x with the variable 2 again. So when we return do something, guess what's going to happen? So now we are here. So we return from the do something, and now you can probably guess what's going to happen. This part of the stack, this stack frame is cleaned up. We do no longer have this stack frame. So let's change this drawing here again. Let's get rid of this one. And you see, we are back to the original stack frame, which is exactly that. So now our x has the value 1 again, although somebody else created a variable x with value 2 and later on even a variable x with value 3. But because they were living on the stack and the stack was cleaned up, we get the original status of our program again. We get the variable x with value 1. And of course, when our program exits, when we exit even the main method, everything is cleaned up, the rest of the stack disappears, our memory is freed, and that's it. That's the idea of a stack. And the two things that you must remember is, by default, structs live on the stack. That's the first thing that I want you to remember. And secondly, every func has its own stack. I showed you that. So whenever you call a function, it gets its own stack. To be more specific, its stack frame. Okay? So this is what I want you to remember, and now you understand how structs work. Good, let's clean up. Now let's think about what's happening when we do not use structs, but we use classes. Okay? Let's try that. Let's, for instance, say, what are we going to do? Let's read a file, okay? Var text equals to file read all text, something like this, myfile.txt. Now let's think about what the data type of text is. And you see it here. The system tells us that this is a string, as you can see here. So let's write the data type here, string, and press F12, go to definition, and let's take a look what string is. Ah, interesting. You see, the string is a class, no longer a struct. So I told you already that classes live on the heap. Well, that's partly true. The string, the variable text, lives on the stack and on the heap. Let me show you what this means. What the program, what .NET essentially does, it's going to allocate a piece of memory. Let's say it allocated this part of the memory, okay? Let's say the file contains the text hello world. So it says hello world. Okay, this is the content of our text file. So it allocated this piece of memory here. Let's do the following. Let's simply draw a border around it. So you see, this string now is allocated on the heap. But the problem is that if you just allocate memory on the heap, you will never find it again. Just like in a real heap. If you put something on a real huge heap, you will probably never find it again. So what .NET does is a very neat trick. It stores a so-called reference. In C, you would call it a pointer on the stack. So essentially what we have is we have a variable called text here. And this variable text, let me draw something here for you, an arrow. This variable text is essentially only a reference. Let's call it a pointer to the memory on the heap. So it's a combination of stack and heap. Understand what I mean? Now, the same is true as before. If we create a method static void to something like this, and then we read a different file here, maybe my other file, see it here, and this other file contains maybe hello universe. Then .NET will again allocate some memory. I will not talk about the strategy, how .NET allocates memory exactly. I will simply visualize it anywhere on the heap. Let's say this is hello universe, something like this. So this is now this memory here. Let's draw a border around it. And because we have a new method, we will get a new stack frame. So let's do exactly what we did before. Let's draw a line down here. Now we have a new variable text on the stack, just like with X and Y that we did before. And this new variable is now pointing to another piece of memory here on the heap. So you see, these variables, these class instances, these objects are always a combination of data on the stack, which contains a reference to something, and data on the heap, as you can see it here. Now, if we allocate more, we could do more. We could allocate maybe an image. If we just, let's say this is a byte array, image. And here we simply assume here, okay? Here we read an image from the internet. I will not discuss here in details why and how we read an image from the internet, but imagine that we did it here. Then we would have, again, a piece of memory allocated. Let's draw a border around it. Let's say this is our beautiful image. Please use your, image. Please use your imagination, okay? And then we have on the stack this image variable, and this image variable is, I think you can guess it. This image variable now again points to the image on the heap so that we can find this image. Got it so far? I hope you understood so far how the stack and the heap works. Let's go one final step further. Let's create our own class, okay? Class, this is our my own file class, something like this. This class, my own file, contains a constructor, public my own file. And this constructor will read, again, a file and store it inside the class. So we will say string text. And here we will say text equals file read all text, my third file. And this file, let's assume it contains hello C#, something like this. Now inside of do something, we are going to create an instance of my own file. Okay, so we will say var mof, like my own file, new my own file. So what is going to happen now on the stack and on the heap? The first thing that is going to happen is that the system will allocate memory for your object, for your instance of my own file. What is my own file? Is it a struct or is it a class? Well, it is a class. Therefore, my own file lives on the heap. So here we have, let's mark it like that, we have maybe here, we have a little bit of memory, and this one is the my own file instance. I will just say my own file obj like object, and we will have a variable on the stack which is called mof, and this mof variable points to, this one here, points to my own file. You see it here. So now we have the instance of my own file living on the heap, but it's getting more complicated. Because as you can see here inside of my own file, we have a member variable which is called text, as you can see it here. And this text is now read. Now what is the data type of text? It's a string. Where does a string live? On the heap. So therefore the following is going to happen. The string is allocated hello C#, something like this. Let's mark that one here. And guess what? Again, we have a reference. we have a reference, but this time the reference is not from the stack, but the reference is from the heap. So we now have two steps. MOF, this variable, is on the stack. It points to my own file, which is on the heap. Now, inside of my own file, we have another variable which is allocated on the heap, as we have learned before, and here we have our hello C#, and therefore we have a chain of objects. So this one links to this one refers to that one, and that can go on and on and on and on. We'll talk about more complicated data structures in the upcoming weeks. You might ask yourself, well, what's going to happen if we add a struct to a class? Something like int x equals 42. If we do that one. I told you so far that structs always live on the stack, but not in this case. Because in this case, our struct is part of a class. And therefore, it's important to note that this x here will live inside of the myOwnFile object. So this is part of this myOwnFile object. So remember, if you have a struct which is part of a class, this struct will then live together with the class on the heap. It will not be separately allocated on a separate place on the heap. That will not happen. Okay? It is part of the object, but it now lives on the heap. I know that's a little bit complicated, but I think with this illustration, it should be possible for you to understand these things. Okay, now let's think what's going to happen when we return from do something. When we reach this return statement and when we exit the do something, maybe this do something is called here. So we exit the function here, so we reach our program here, so we are here. This is where we are in the flow of our program. What happens? I told you already what's going to happen. The system is cleaning up the stack. So this is deleted and our old stack frame becomes active again. So let's go here. Let's remove that line, and now we have a problem because this reference, poof, gone. This reference, poof, gone. This reference, poof, gone. But we have a lot of stuff living in the heap which nobody is using anymore. That is a catastrophe. This is what you typically would call a so-called memory leak. Memory leak. Because you allocated memory on the heap and suddenly it's there, nobody remembers it anymore, but it's still inside of memory. And now I have very, very good news. In C# we have something we call the garbage collector. Yes, this memory part here, this part here where you allocated stuff on the heap is considered garbage because nobody references it anymore. And the garbage collector will regularly run. I will not go into details when and how, just accept it will regularly run and remove all the garbage automatically. So what we have here, let me remove the borders here, none. So the garbage collector simply cleans up everything, and the only thing that remains are the variables on the stack and the memory on the heap, which is referenced by these variables. The rest was considered garbage and was removed. This is very important in C#, and this is the task of the garbage collector. It runs regularly every few seconds, or yeah, let's just say every few seconds it runs and it will delete and remove all the memory. It will free the memory. This is the word that we typically use in your computer. Now, if you use a different programming language, like for instance C, you also are taught C in this year, then you do not have a garbage collector. There are languages without the garbage collector. If you have a language like C, which doesn't have a garbage collector, you must manually free the memory. You cannot just allocate memory and then rely on a garbage collector. No, you have to explicitly tell C#, in this case, you have to explicitly tell C to free the memory. And if you forget to free memory, you have a memory leak. Your computer's memory is going to fill up and fill up and fill up and fill up and fill up, and at one point maybe you get an out of memory exception because all the memory was blocked by memory that you do no longer use. So memory leaks are something bad. Luckily, in C#, typically you do not have memory leaks. Again, technically, things are in reality much more complicated, and yes, you can have memory leaks in C#, but this is a story for another year, for when you are more advanced C# developers. For now, let's just assume that C# protects you from leaking memory. So we can make sure that this memory is freed. Nice! I hope you understood stack and heap based on this description. However, I have one last thing for you, which is important also for the upcoming homework. So let me simplify our code a little bit on the left-hand side. And now, as a last thing, I would like to talk about optional data. Maybe you have seen already this question mark at the end of some data types, something like int $X, something like this. If you use this question mark here at the end, it says this is an optional value. So we can assign X a value, something like this. And if we have something like this, then our X here has the value 1. That is correct. But what value would we assign X if it shouldn't have a value? And there we have a new keyword in C#, and this keyword is called null. Null means that X currently does not have a value. So you can simply assign null, and null means doesn't have a value. You can easily check if X has a value. You can say if X is null, or you can say if X is not null. So you could write something like this. You could say this one, X is null. This is absolutely valid code. Okay? Another way you can write it, which you see very frequently, is there is a property which is called hasValue, and you could say something like this. This is exactly the same. I personally recommend that you write X is null in this case, or not null, depending on what you need. So this is a null value. And you can write this question mark at the end of each data type. The same is true for classes. Let's take a class, string question mark text2. See that one? So that will be here a variable in the stack, text2, but this time no memory is allocated on the heap because text2 doesn't have a value. We can assign here null, and that is essentially an empty, a null pointer, a null reference. We call it a null reference. It doesn't reference any memory on the heap. This is what we can do with this question mark. Later on, when we say text2 equals to file.readAllText, my superfile.txt, then we allocate some memory on the heap, content of my superfile.txt. By now you understand how this works. Let's put it that way, and let's say this is again a border, and then we have a reference, something like this, and now text2 refers to the content of my superfile text. This is exactly what's going to happen in this line. But if we say text2 equals null again, guess what's going to happen? If we do that, we lose this reference. And guess what the garbage collector is going to do? The garbage collector is going to recognize this allocated memory on the heap, and it will simply free this memory automatically for you. And text2 is null again. So this is what we call a null reference. A reference that is empty. It doesn't contain any values. And you can use this optional question mark here with reference types, meaning classes, and value types, meaning structs. I hope this description was useful. We are going to practice. We are going to practice this over and over again. We are going to do exercises using classes, using structs, using null references, allocating memory. This is what we are going to do in the upcoming weeks. So you really will understand the differences between stack and heap, between structs and classes, and you can successfully work with null references and optional data types. Thank you for listening. Thank you for watching. I hope this video was useful.